Welcome to lesson 3.3. In this lesson, we're looking at models. So we have three types: linear, exponential, and simple quadratic. And we're going to focus on linear models for this module. So some things to remember or know is slope is the rate of change. We want to remember that as we look at four representations. So here we have blood alcohol level again, and a graph depicting the linear relationship. So if slope is rate of change, that is change of output over the change of input. You might also remember rise over run. So on a graph, we have our rise, which is the up and down, and that's over the run, the horizontal, the side to side. So the slope-intercept form of a line, y equals mx plus b, where m is the slope and b is the y-intercept. So let's look at the first one. Write an equation of a line with slope 4 and intercept of 5. So that means we're going to plug in 4 for m and 5 for b. So y equals 4x plus 5. And here's an application. So Terry's elevation E, if he's skiing down a steep hill, that is the formula E equals 2800 minus 60t. So 2800 is where he starts, and 60t is the change. So he's going to start at that elevation and decrease by 60 each time. The minus tells me it's decrease. So when you're graphing the line, you always want to start at the y-intercept and then use the slope to tell us where the next points are going to be. So let's sketch y equals negative 4/3 x plus 1. First, place a point at y-intercept, so that'd be the 1. And remember, it's on the y-intercept. And then what I usually try to do is put the negative on top. So I'll go down 4 and then to the right 3. And then I'm going to connect those 2 points. Now the computer might do that for you automatically. So here we have a problem situation for a fundraiser. No matter what, they're going to pay a setup fee of $75, no matter how many shirts they sell. So if they sell one shirt, well, they sell it for $15. And then after the $15, they have to pay $5 for making it. So that would be negative 75 plus 9. Well, actually, sorry, plus 10. And then I'm going to keep doing that for each of the numbers to plug in. Next one. So I was going to make a linear model. I would say negative 75 plus 10n. So I always have to start at the negative 75, and then I can go up 10 each time. So that's what I would graph. If they sold 30 shirts, I could just plug that in for n, and then it'll give me the answer. To figure out how long it'll take them to get to their goal of 500, I would plug in 500 for p, and then solve for n. So here we have the next situation, lattes. So a local coffee shop offers a coffee card that you can preload with money. So we have B for balance and coffee after tea weekdays. So the coffee card starts with $50, and then each short soy latte is $2.63. So it's going to subtract $2.63 each day, which is tea. And then we want to figure out when it's going to run out of money. So we're solving for t. And we're going to plug in 0 for b, because that means there's no more money. That'll tell you how many days are left, which when I do that, I get 19.